Hey everyone, my name is Sean Falconer, and I'm excited to be here to talk about unleashing real-time AI-powered innovation with Confluent in Microsoft Azure. At Confluent, I work in the technology strategy group. This group really sits at the nexus of product and go-to-market, and I lead our AI strategy and thought leadership. I've worked in the space for the bulk of my career, starting as an AI researcher and then moving into applied AI across various roles in the tech industry, including starting my own company in the space. And I would say through multiple decades of working in AI and technology, this by far is the most exciting time to be working in the space. And I would say in tech in general, because of the sheer explosion of innovation that's happening right now, which is some of the things that we'll touch on today. Now, given this innovation, it's lots of exciting things, but it also introduces certain challenges which we need to be able to solve in order to make these applications a reality. In terms of the agenda, we're going to go through a little bit of introductory material. We'll talk about why every AI problem is fundamentally a data problem. We'll also talk about Confluent Data Streaming Platform and what is our role in this sort of emerging AI stack. Then we'll get into a technique known as retrieval augmented generation, or RAG, and we'll talk about the steps involved there. And then finally, get a little bit hands-on with how to build real-time AI applications with Confluent Data Streaming Platform and Azure. Now, over the course of the last decade, AI has really emerged as a transformative technology, reshaping the reality of what we can do with our lives in terms of how we interact with various technology, from our smartphones to autonomous driving to how businesses interact with us through the use of things like chatbots, virtual assistants, tailored offerings. All of these things are having a massive impact in the terms of consumer experiences, as well as being on the technology side of the way that we think about building these types of products. And in the last year, McKinsey published an article on the economic potential of generative AI, where they estimated that Gen AI could add the equivalent of 2.6 trillion to 4 trillion annually across various use cases. So there's potential, huge total addressable market, which is, of course, generated a lot of the interest and sort of hype around this technology. But fundamentally, what is different about generative AI? So we've kind of gone through, I would say, three distinct eras or waves of AI. We've had sort of predictive ML or purpose-built models, which is really like the AI that I grew up in and what I studied in school and was a researcher in. And we've been using this type of technology for decades now in software, and we'll continue to use it as well. Just because foundation models and generative AI is here doesn't mean that this goes away. It still has a utility in a variety of different use cases where it makes sense to use a purpose-built model. But with purpose-built models, what you did was you took very domain and application-specific data, and your data science team and your data engineers would work with that data, and they go through this sort of offline batch process to build a very purpose-built application domain-specific model. And those were great. And then we'd use it for that application. It doesn't get updated very often, but the challenge there was it was very hard to take that model, this purpose-built model, and use it for something new. I could take a fraud detection model and start using it for image classification. And really the foundational shift that's happened with generative AI, besides the generative capabilities of the models themselves, is that these models are infinitely reusable. Only a handful of companies in the world have the resources and the expertise available to build these models, and are trained essentially on all pieces of information available. So very different than sort of domain and application specific information. So a handful of companies build these models, and then they package them up and expose them through essentially a REST API. And then as an application engineer, I don't need to know anything about deep learning and neural networks and reinforcement learning and so forth to use these models for my application. I essentially hit an API endpoint and I get the AI magic out of the box, which has really democratized access to these models to be able to build all kinds of new experiences, which is really exciting. However, the challenges to make the models application specific still remain. These models are incredibly smart about general information, but really dumb when it comes to essentially your business information, your customer information, your private information, because it was never trained on any of that data. So how do you get it to have access to that information? And really that comes through techniques like retrieval augmented generation or essentially prompt time assembly. So when I'm asking the model to do something, I need to go and retrieve additional data to give it the right contextualization so that the model can produce essentially a response that makes sense for my particular application. And that's predominantly the way that we essentially give domain-specific data into the model. And then on top of that, we've had these two eras, and now we're entering essentially a third wave of AI, which is agentic AI. So to put this in context of the physical reality, with predictive AI or purpose-built models, essentially it was like a reflex where you learn it once, but it's hardwired. Touch a hot stove, pull your hand back. And in the context of something like customer churn, we could use one of these models to predict churn, but then we have to hand that off to a person to do something about it. And with generative AI, what we've done is we've introduced essentially a brain so that can reason and respond. So now we don't need to just predict customer churn. We can actually have a generate response to the customer questions and make it sound like a person. And then with agents, what we're doing is things get even more interesting because we have this full body system that can reason and coordinate and take actions. And going back to our customer use case, here now an agentic customer service bot can not only respond to customers, but it can make decisions like deciding to give someone a refund and executing that task. So essentially agents are software systems that have the agency to make decisions about what that workflow of execution is. They do this through a combination of tools where it's gathering information and data, using foundation models like a brain to make decisions, and then essentially acting within an environment. But with each wave, what we're able to do is essentially offload more and more work that historically a person has to do to these asynchronous software systems. However, in order to actually deliver sort of on this promise of generative AI and agentic AI, you need trustworthy real-time data, or you can't really derive value. So let's take the specific example where I'm interacting with a Gen AI powered assistant from United Airlines. When I ask something like, what is the status of my flight to San Francisco? The model has no idea about who I am and the status of my flight because it was never trained on that data. I have to provide that information behind the scenes during prompt assembly. And where does that information come from? Well, it probably comes from the identity system at United and the airline reservation database and maybe other systems as well. And then later when I ask, is there another flight available to the same city that will depart and arrive sooner? How does it know the same city means San Francisco in this context? Because every model interaction is stateless. So I have to keep track of the history and pass it in as part of that context, along with the information about the similar flights that will depart and arrive sooner. So I have to essentially compile all this additional context, keep track of it, and optimize it so that I'm giving just the right context at the right time. And for many businesses, this is a really hard problem to solve. And fundamentally, what ends up happening for all businesses is that all their AI problems essentially are data problems. How do you liberate the data from all these disparate data sources that exist within enterprises? Enterprise has on average 1,300 databases, not to mention all the SaaS systems and other places where this information can exist. But if you can't get that data and you can't provide that right contextualization, then you end up in a situation where you can potentially have hallucinations and generate mistrust. AI hallucinations happen when models are essentially forced to do work with outdated or incomplete or decontextualized data. And the result ends up with inaccurate responses, unreliable insights, loss of trust with your customer or your consumer. And unfortunately, traditional batch-based data pipelines can't really keep up with the pace and context that AI needs because they're delivering stale snapshots, not real-time reality. So essentially, you're relying on the model making decisions or providing information based on stale data. And that's why real-time, contextualized, trustworthy data is really critical to AI success. It minimizes the risk of hallucination, enhances model accuracy, ensures AI delivers decisions that you can rely on. And fundamentally, that's why you need to essentially get your data in check before you can start to really take advantage of some of the innovation that's happening in the world of AI right now. However, this becomes a challenge for many businesses because a lot of businesses have very messy infrastructure. Enterprise businesses, you might have on-prem, hybrid cloud, multi-cloud systems with thousands of different databases. And how do you essentially get the data from all those places so that you can provide it at the right time? And on top of that, the speed of innovation is happening really, really fast in the world of AI. There's new models all the time. There's new application frameworks. And just like we saw a shift from traditional applications away from monoliths to microservice-based architecture, the same is true for AI. We need to build these applications in such a way that you can decouple the AI architecture from the start so that you don't risk vendor lock-in, a brittle integration, or something where the innovation passes you by before you ever even launch the application that you want to launch. And then the third big challenge for enterprises is around essentially governance and security. Governance and security are already big challenges for any business dealing with data in the worlds of rows and columns. And then suddenly when you introduce essentially a stochastic model that is really just an aggregate of a bunch of weights, the tooling available to solve governance and security at that level is extremely immature. You have to essentially shift a lot of those problems left to the process of essentially when you're preparing that data to be ready for AI. And these are some of the reasons why many companies are struggling to implement AI successfully within their use cases. In fact, according to a recent report from S&P Global's Trends in AI report that surveyed 1,500 AI decision makers, data management is one of the top inhibitors of essentially AI ML deployments because essentially they're not able to get the right contextualization to generate reliable results. We talk so much in AI about all the things these foundational models can do, but fundamentally the right question to be asking as a business is what can they do reliably, and reliability really comes down to how good is your data posture? How good are you at essentially getting that right context at the right time? But this is exactly the problem that Confluent solves for our customers. It's a radically transformative approach to essentially transforming your business into one that has data available at its fingertips all the time in motion as close to the source as possible. Confluent Data Streaming Platform enables you to construct a unified real-time knowledge base of your customer by tapping into the feeds of information as they actually change. We can make your data AI ready in real time. We can bridge your legacy systems and your AI stack with fully managed connectors, an open API, native stream processing, governance, hybrid and multi-cloud capabilities, and Confluent can secure and govern all your AI data and set it in motion to unlock the power of AI within your organization. And really what is at the heart of this is Confluent makes data a first-class citizen, enables free interoperability of data in real time everywhere, where processes happens immediately and continuously. Data is governed as it moves across the enterprise, meeting the security and compliance and governance standards of your organization. It's instantly consumable everywhere where it's needed, whether it's your AI systems, vector databases, or your AI-powered applications, so you can accelerate the pace of AI innovation. It's a fundamentally different way from many of the traditional data at rest architectures. It's event-centric by design. This means that you can capture real-time events, convert them into appropriate embeddings, so your AI tools, apps, and models can apply business logic in real time. It decouples your architecture. Really, I think the true gift that technology like Kafka has given the world is decoupling of your services, decoupling of your teams. It's what makes highly scalable systems that we all use in our everyday lives essentially possible. And data in Confluent is immutable, it's persistent, enables you to aggregate and store all your data infinitely for a single source of a real-time truth. And because these streams usually contain somewhat raw information, you need to be able to process it, you can refine it. So things like stream processing is how you transform, filter, aggregate, and even do things like Gen AI-based transformations on that data, generating vector representations of the information or enriching the data in some way, while also being able to govern all that data all essentially through one unified platform. So now, as we turn our attention to AI, in order to make this a reality, most Gen AI applications have sort of 4 primary steps. The first step is around data augmentation. This is all about preparing your data, ensure that your Gen AI app has access to the most recent, up-to-date data sets, contextualize that data in an LLM prompt. It's about building that real-time knowledge base for your applications. And then the second step is, like, once you have that data available in a vector store or some other type of data store, is inference. How do you contextualize whatever your users are asking for and ensure the applications are built to handle those responses? The third step is workflows, or you could extend this to things like agents. How do you take natural language and synthesize that into high quality information, apply contextual reasoning on the fly, connect it to other data systems, other SaaS applications to take actions within this sort of messy enterprise architecture? And then the final step is really post-processing, which is enforcing business logic, compliance requirements with more transparent models, re-rankings, all kinds of things go into this to ensure that LM returns a reasonable response. So let's start to look at how companies are actually applying Confluent as well as Azure AI in the real world. So first, we can, of course, have things like predictive analytics. Traditionally, models are trained on batch data to become quickly stale. With Confluent, you can have fresh data that's continually streamed into Azure ML and Synapse, helping the model stay accurate, relevant, adaptive in real time. So you can potentially do online training, or you can use those models in real time to do things like thematic analysis, other types of analysis, anomaly detection, and so forth. With generative AI chatbots, you can be streaming live customer and operational data directly into those bots. Companies can provide responses that are highly personalized, relevant, up to the second. This means no more, generic answers, just contextualized, intelligent conversations that drive better customer engagement. And finally, AI-powered automation. By streaming in real-time signals, things like fraud alerts, inventory changes, customer behavior, organizations can automatically trigger workflows and decisions. This reduces latency, improves operational efficiency, helps teams respond faster to change. Even at Confluent, we use a combination of Confluent and Azure AI to actually do lead scoring. So as leads come in from Salesforce, we take those leads, stream them into a Kafka topic, use stream processing, and essentially the models available from Azure to score those leads in real time and feed that back to the sales team so that they can start essentially working those leads as fast as possible. So, fundamentally, why Confluent data streaming and Azure AI? Well, what we're going to do is look at how to essentially address each of those 4 steps of RAG, from essentially data enrichment all the way down to actually using some of this information within an application. So we'll look at how Confluent integrates with Azure OpenAI for generative AI, Azure Synapse for analytics, Microsoft Copilot for business productivity, and how streaming essentially helps reduce things like model drift and ensures relevance. So when we use a combination of Confluent and Azure AI, you can migrate essentially your data from anywhere into Azure, because Confluent can connect to all those different disparate data sources. We have over 150 different connectors to all the most popular data sources. And then as the data is essentially flowing in real time from a stream in updating and changing, you can essentially augment that data so that's ready for AI. Either generating embeddings or vectorizing that data in real time and then syncing it down into a vector store, or enriching the data as it's in motion to various downstream services. So you could take unstructured data and essentially apply a schema to it to structure it so that now you can consume it within a warehouse. And once you have the data ready for AI, you can build your cloud native AI applications and build these using an event-driven approach so that you decouple your customer-facing applications from the AI magic that's happening behind the scenes. This gives you tremendous flexibility to treat everything as a modular component, so you can substitute the technology as new innovations become available. So when we look at cloud services, they have to have essentially agility and cost benefits, but excuse me. When we look at cloud services, they have to have the agility and cost benefits, but there really is no easy way to extend valuable data from on-prem data services to the cloud. Dependency on a data service being fully migrated to the cloud can actively delay modern app development projects. I've talked to many customers who spend years essentially trying to migrate to the cloud, and it makes it difficult to take advantage of the latest innovations. But with Confluent, you can modernize your on-prem data services and applications without the heavy lift and shift with a consistent data architecture using Apache Kafka across those essentially environments. You can essentially connect your on-prem systems to your cloud systems, leveraging our 150 plus Confluent pre-built connectors to stream data from those on-prem data services to Azure. You can increase agility, reduce your TCO with freeing up your resources to focus on value generating activities instead of managing the infrastructure. Businesses also, they fail to capture the most value from real-time data due to essentially batch-oriented data processing and a scalable point-to-point messaging. A lot of system companies really start to suffer under the weight of so many ETL pipelines, these batch processes where they're managing sometimes over 10,000 different ETL pipelines that all have some level of dependency on each other and becomes really brittle, really hard to manage. But with Confluent, you can ingest and process streaming data such as quick streams, IoT devices, log data in real time with enterprise-ready Apache Kafka fully managed on Confluent Cloud or self-managed in Confluent Platform, or even bring your own cloud with WarpStream. And you can stream that data into Azure data services for low latency real-time analytics with those pre-built connectors for Azure Data Lake Gen 2, Databricks, Azure Synapse for analytics, and leverage ML models to get real-time insights from incoming data and take those insights to gain real-time insights, or take those insights, so that your business can actually share those with the applications as you capture them. Essentially, getting more value out of the things that you are typically doing within the data layer, but being able to feed that back into your applications and actually have an impact with your customers in a much faster way. And then finally, you want to be able to connect all your existing apps, things like edge devices, your data stores into data stream, govern them as close to the source as possible so that you're using data streaming to essentially clean the data and get it ready for use by AI applications as well as your analytics layer. So you're not just dropping dirty data essentially downstream, but you're having it essentially ready to be consumed by all those great AI tools immediately as soon as it's available. And then once you've done all this work, you now have a system where data is immediately available to be used by Azure AI as that data actually changes. The change is captured and updated directly within the vector store. So you have that available at your fingertips. And on the application side, in this example, the airline customer support doesn't need to be tightly coupled to the AI services. They shouldn't know anything about that. Essentially, it's just simply produce and consume events. And this gives you the flexibility to scale all those services independently and experiment with different technologies as they become available. All right, well, that's enough theory. Let's take a look at how this actually works in practice. I'm going to pass this off to Brenner for a demo. Thank you so much.
Great. Thank you very much, Sean. Hi, everyone. My name is Brenner Heintz from Confluent. Have you ever heard the joke about how if you send 10 salespeople into 10 different sales meetings, they'll find 15 different ways to sell your product? Your marketing team can spend months and months crafting the exact perfect messaging for your company and your product. But if no one repeats that information, what's the point? If when your salespeople go out into the field, all bets are off and no one's referencing the internal documents that you have about how you should speak about things, the scenarios in which you should say this and not this, then you sort of have a sales team that's gone wild. And that problem is why we built this. It's a real-time meeting coach system that listens to sales conversations and provides highly contextual, relevant, timely advice using your company's actual sales documents. So let me show you how it works, and then I'll explain how we built it, and we'll get into the architecture. So look what happens when a customer says this. Do provide support for difficult data migrations. How long do they usually take? In just a moment, you get a response back from the system that's based upon the ground truth of your knowledge documents. This system lists the sources that are retrieved from your corpus of knowledge documents, like an implementation concerns playbook. And then it talks about its reasoning for why it chose the specific parts of those documents that it did to inform its response. So in response to asking about these difficult data migrations, it says, I understand. We allow for a smooth transition within 4 to 6 weeks, typically, ensuring data integrity with rigorous checks. For example, Meridian Financial achieved full operational status in just 5 weeks. That was pulled directly from the documents that were provided to it. So essentially what we've built here is a real-time retrieval augmented generation system that allows you to provide the best context and advice in the moment as possible. No more going off script or making things up. This is your official company messaging delivered at the exact moment that messaging is needed, and it really counts. So think about having a tool like this that instantly lets you absorb all your company's sales knowledge. It can read all your battle cards, your competitive sales documents, and gives reps the right information at the right time. Every company has a treasure trove of these documents, but they're typically not used that much, and they're only as good as gold if you use them. This basically gives a brand new salesperson a superpower when they have access to this sort of system. All of your company knowledge synthesized into the perfect advice for each specific customer situation. And it's always current and up to date because it's always using your latest documents. So this isn't just another chatbot. This system is always current, as I said, and it uses these simulated synthetic documents for our purposes that we created for a company called Insight CRM. And we provided lots of these documents. And as you can see, they're rather long. Some of them are anyway. And they have lots of information in them. But these are company specific. And what works for this company may not work for yours. And that's the power of this as well, is that it's contextual information that makes your sales conversations that much smoother and more impactful. Because this system is context aware. It understands the whole conversation, and it's practical. It really solves a real problem that costs companies millions of dollars in lost deals. And the technical side is impressive too. So here's what we built. There are two parts. Here's a pipeline architecture. There are two separate tracks to this. There's the knowledge processing track, where we process and create embeddings and vectorize your existing knowledge documents, those sales documents I talked about earlier. And then there's a query processing track, where we take those things that your customer is saying in the chat or in a real meeting, and in real time, we add those to the RAG pipeline, create embeddings, and do vector search on those documents based upon what's been said in the meeting. And from there, we then take those most relevant documents and feed those to a prompt with an LLM where we say, extract the most useful parts of these relevant documents and include them in your message. And that's what we've done. So as I said earlier, we start with your sales knowledge, these sorts of documents, and every company has these. Using the Azure Blob Storage Source Connector, we read these markdown documents into the Kafka topic called Messages Prospect. That's the very first topic that we show in that architecture diagram. Then we create embeddings, basically turning words into huge vectors that capture their meaning. We use Azure's OpenAI text embedding Ada 2 model for this. Here you can see within the Azure AI Foundry, we've deployed 3 different models here. We're only using 2 for today's example. We're using text embedding Ada 2 to create those embeddings. both of the documents and the real-time messages. And we're using GPT-4o Mini for the text generation in the finest step. Words of the wise here. When you are deploying your models in Azure AI Foundry, make sure you increase the quotas for the number of tokens. It starts with something super low, a quota of like 1,000 tokens per minute, which you can chew through very, very quickly. Next, now that our large language models were all set up and deployed in Azure, we're ready to start processing documents for vector search. So Confluent Cloud has a cool feature called Flink Actions that allows us to do transformations on our data, including creating embeddings. And this is a pretty nifty feature because it means that you don't have to learn the exact semantics in SQL of how to do these embeddings. We have a Flink action that can do that for you. So if I hop over to the data portal and I find my original topic where we drop the documents, just the raw documents in, I can then click this button that says Actions. And from here, I can choose to transform my data. And one of these options is Create Embeddings. From here, I just choose which column I want to create embeddings from. We're going to do, of course, our document text. We have an output topic that we'll create. We'll create a new model here. We'll call it OpenAI 2. We'll use Azure OpenAI. We've already set up a connection there, and Flink SQL will use that connection to call out to this model and send data and receive back those embeddings. We'll use the existing connection that I just mentioned, and we can even enable chunking of our documents. We can have about a chunk size of about maybe 400 approximately tokens or characters. And maybe we do an overlap of about 20% or so. From there, all we have to do is show SQL, and we can grab that SQL that will create these embeddings for us. So we've already handled the very, very first step beyond ingesting the data into our topic. From here, we can, of course, I'm logged out. Let's see. Try again, please. Let's try this again. From here, now that we have embeddings from our knowledge documents, again, if we go back to that architecture diagram, we just created knowledge embeddings chunked from these knowledge documents in this track. From here, we want to send those to a vector database. And for that, we're going to use MongoDB. We use built-in connectors as part of Confluent Cloud that are super easy to use. Here we have the MongoDB Atlas Sync connector. And what this allows us to do is to create essentially an external table within Flink that we can reference and that we can pass its values in the next step when we ultimately do a vector search. And so you set up an API key and you connect to this. It's very easy. You simply specify the collection name and the database name you're using. In my case, it's KnowledgeDB and knowledge. And then you load your documents, and here they are. So we started with all of these documents, and here we have document ID and name to keep track of which text chunks belong to what. And we then have embeddings too, these huge, huge vectors of 1,500 some odd points. And it kind of boggles the mind when you think about it with how many dimensions there are. But that's what enables them to be so accurate. So from here, we can use the vector search function within Confluent Cloud and Flink. Of course, it's having trouble logging me in. And I had a bunch of these teed up. Give me one moment here. All right. So let's go to Flink here and take a look at these statements. This is what I had queued up earlier. All right. So we have gotten the data into those embeddings, right? And then we use ML predict here to actually call the embeddings, to have those created. It calls out to OpenAI, uses the embedding model. That's the function that does it here, this ML predict function. And we do a lateral table. It just adds that on to the existing table that has the message and all that. Next, we create the message prospect RAG results table. Here we actually are doing the vector search. You'll see that we have vector search right here in the SQL statement. And what we're doing here is we're passing the message in, the speaker, and we're getting back those search results, which come in the form of those 3 chunks of text. And those are going to be the basis for our response later on. Next, we can, in the final step of our process, and again, I'll go back to our original architecture here. We just talked about this, getting our RAG results back by running the vector search. The final step in our process that involves the LLM is we're going to use GPT-4o Mini and we're going to pass it in all of the context that we just retrieved through this vector search. And we do that, here we go. We do it with this statement. We have a big, huge prompt for this LLM, which is going to generate a response for us that you saw earlier in the UI. And what we do is we pass in the message that the prospect sent in the chat or said live in a sales meeting and was transcribed through speech to text. We pass in those RAG documents, those 3 documents and the chunks from them, including what those documents are so we can reference them as well. And then we ask for a JSON response back so that it's easy to have a standard data format that these responses take that we can then pass to our UI. So that's a pretty good, gives you a pretty good sense of sort of how we call these functions in Azure OpenAI to do the embedding and to do the ultimate inference at the end that's contextually aware, that's grounded in your documents, and it really works rather well. And to give you some technical highlights, this is completely event-driven. As new documents are added, they're automatically processed and available for retrieval. So you can modify documents, you can add new ones, you can remove documents from your corpus, and those changes are propagated downstream. Vector search happens within seconds through Flink SQL's AI functions. These call out to powerful models, as you've seen, and they're very capable. And I've been really surprised and quite happy, actually, with how well the vector retrieval and search has done, creating contextual information. And I think Confluent, just to wrap up here, since we've gone over the architecture now, this is the kind of app that I think more folks can and should build on Confluent's data streaming platform, and here's why. First of all, everything's event-driven. When a customer speaks, says something new, has an objection, that's an event. When documents update, that's an event. And our platform is built to handle those sorts of streams reliably. Second, Flink SQL lets us process these events with simple SQL, no complex, coding or, esoteric formulas needed, right? I showed you the Flink actions from earlier that make it really easy to do embeddings. And there's a couple simple SQL commands that you can use to bring it all together. And third, I think the connector ecosystem really pulls this whole thing together and makes it much, much easier than trying to build complex custom integrations, keep things working, and all that. with, we ultimately also land, I forgot to mention, we land the data ultimately in Cosmos DB at the end of the day when we're all done with it, because the messages and responses are very, very valuable for retraining your model later, additional context, that sort of thing, as well as, an audit trail and all that. So here you can see we have the messages, prospect, RAG, LLM. It's very wordy, but I assure you the messages themselves and the responses that we get back from the system are all maintained there. And we use the Cosmos DB sync through Confluent Cloud to be able to do that. So to wrap up here, I think this is an innovative way to do something really useful with the data streaming platform. But I think it's just the beginning, and I think you all are creative folks, and I hope this has just inspired you a little bit to try something like this, because it's really easy to get started on the data streaming platform. Flink SQL has these great functions that make it really have, it's a great experience. And I don't want this demo to end here. There's a fantastic GitHub repo that you can check out that has all of this on it, including Terraform that you can use to easily spin this up and try it yourself. So thank you very much. And with that, have a great day.